Hello and welcome to another Tech Talk Tuesday. I'm your host Shazad Ali. I'm the Principal Solution Architect here at Aviatrix, and with me I have Matt Kazmar joining us today discussing the common design patterns for next generation firewall insertion in AWS. So before we begin, I'll just give you a quick intro of our platform. So Aviatrix Cloud Networking Platform is available in all major CSPs, the cloud service providers marketplace, and it starts from the controller. That's the virtual machine or EC2 instance that you deploy under your account or your subscription. And that controller is basically the brain of the solution. So the architecture decouples the control plane from the data plane. So all your interaction to the platform and to the cloud is done through this Aviatrix controller. You can drive this interaction using the user interface, the graphical user interface, or Terraform, which is a very popular choice for a lot of enterprise customers today. Then the second piece is the Aviatrix Gateway. So Aviatrix gateways are again the virtual machines or EC2 instances deployed under your account or subscription, and they are actually providing the advanced networking and security for your cloud deployments. The controller is also smart. It talks not only to the Aviatrix gateways to program the data plane component, but it also talks to the cloud service providers. For example, Azure, AWS, Alibaba, Oracle, and GCP. So we know exactly what's happening in your cloud deployments. We know about all these native constructs and we can program and we can control them. But not only that, if you notice, we also talk to third-party vendors. For example, Checkpoint, Palo Alto, Fortinet, F5, and the list is very long. I'm not showing each and everything here, but we can actually program it, we can control it, manage it, and make it part of your cloud deployment. And this is exactly the topic we are having today to insert those third-party next-generation firewall into your traffic flows with a zero trust and policy-based architecture. Now, the fourth piece that you see is Aviatrix CoPilot. So this is providing the extreme visibility and operational capabilities for your cloud and multi-cloud environments. So we provide these operational visibility, we provide the data analysis, the intelligence that you need to run this setup. And then we also provide you some visualization that are missing from the cloud service provider portals. So if I take this further, you will notice that when you deploy this architecture, we are solving a lot of challenges for your cloud networking and security needs. So Aviatrix becomes that foundation for your single cloud deployment or in a multi-cloud situation. And to be honest, pretty much all the enterprises are multi-cloud these days. But like I said, there are certain scenarios where you might want to start from a single cloud provider, and then we are solving all those challenges of multi-account, high availability, end-to-end encryption, network correctness. And not only that, when it comes to connecting these clouds in different regions or across multiple clouds, we are building that foundation, this unified fabric that is available between these clouds over the public internet or through private internet the connectivity options such as direct connect and express route. And this is all done through our advanced network correctness and traffic engineering capabilities. So you have this highly available fabric, which is all encrypted, available at your disposal. And by the way, this is a common and a repeatable design. This is very important for you to understand because you have the skill gap challenge, you have different ways of dealing with different clouds. So this is not happening here. We are just making it so seamless for you that you have a same architecture deployed across all the clouds. So like I said, there are a number of challenges we are solving for our customers, and I will encourage you guys to attend our office hours. This is where we can discuss more in detail about your unique situation, about your unique use cases. So our topic is the service insertion and chaining, which is one of the use cases we solve for customers. So when you're deploying your workloads in VPCs or VNet, the prod, the dev, and the test workload, obviously you want to make sure that your your virtual machines or EC2 instances are inspected by these next generation firewalls. And this is exactly what this feature does. It inserts the next generation firewall into your traffic flows so you can provide the security and compliance that you need for your enterprises. Okay, so with that, I will hand it off to Matt, but before we move forward, I will really appreciate if you can put your questions in the QA chat window there so that we can answer them accordingly. Matt, over to you.
Hey, thanks, Shazad. AWS firewall insertion has always been challenging. AWS has their version of solutions. The different firewall vendors have their versions of solutions. And all of it is just kind of complicated and hard to deal with. So first thing we're going to look at is the Palo Alto VM series reference design. Now we look at this design here, and it is active passive and on failover passive active, right? So how are they accomplishing this failover? They are actually calling the AWS API and moving EIPs and other IPs just over to the various instances. And is this really something that's going to be fast, or is it going to take a while? And the answer is it's really going to take a while, because all these API calls can add up to minutes of downtime. So if you have a failure, or you need to fail over for maintenance, or whatever you're doing, it's kind of a problem there. Now enter the Gateway Load Balancer. This is AWS's solution to this particular problem. And look at this diagram. This is incredible. And give you a sec here. Count up the number of route tables that you're required to configure. Yep, there's 10 of them. So these are 10 route tables you have to maintain for just the reference solution. Now, what happens if you have to change your environment? What if it's different than what they're displaying here? What if you have another design pattern? You have to do Ingress. It's very, very complicated, very difficult to maintain at scale. You're going to be spending lots of time either in Terraform or in the portal, just making sense of it all. And considering that, what happens if something breaks? Your traffic isn't flowing the way you expected. It's not hitting the firewall. It's not getting there anywhere. I mean, you're in trouble because there's no visibility in this solution. Now enter Aviatrix Transit FireNet on AWS. We provide a solution to all those hassles. Now here's the first one that we developed before Gateway Load Balancer was even on anyone's radar. And it's a very simple solution from a deployment perspective. We have our spoke gateways here that connect to transit, our traditional transit design. And then on these gateways, we actually associate with firewalls. And these firewalls are all active. So we can send traffic to anybody and get full speed, full line rate, no IPsec, no SNAT required, because we handle the hashing and make sure things are symmetrical. So it works really well. Now here's our architecture with the Gateway Load Balancer. We support that as well. And it's pretty similar here. You have your spoke gateways connect to the FireNet transit gateways. But instead of pointing directly to the firewalls, we point to the Gateway Load Balancer here. And you got different endpoints and different AZs there, as well as the actual Gateway Load Balancer, which distributes the traffic to the firewalls using this Geneve tunnel that AWS has decided to use. But we don't really have to worry about that part because we're just sending traffic to these endpoints. Now, if you notice, there's no route tables listed. There's really nothing to maintain here, because all you do is click the buttons in the controller, as I'll show you later, or run your Terraform script. And we build the connections, we build the route tables, we build the security groups, we build that Gateway Load Balancer. And further, if you actually have to troubleshoot this, you not only have logs from your firewalls here, you have logs from all of these spoke gateways. And I'm seeing a question too about this NAT gateway here. Some of you may be aware that Palo Alto can actually do this without the NAT gateways as of, I believe it's version 10.05. However, we can leave these in there if you like, because in the regular egress design that use the Palo Altos to do NAT, you're going to end up with quite a few EIPs. So it's one of those things. It's a decision based on your design. Do you want 2 EIPs with the NAT gateway with the additional costs of the NAT gateway, or would you rather NAT on the Palo Alto? It's up to you. It both works and works just fine.
So Matt, one question I see here is that in the previous design, there was no gateway load balancer. Obviously, gateway load balancer is the new service from AWS. And the slide that you showed with all the native options, obviously it was very complicated to run and manage. And so what's the difference between this design and the previous one, or why someone would go with this design, not the one without the gateway load balancer?
The reason why you'd go with this design is because the Gateway Load Balancer is supported and going to be more supported by the firewall vendors. So if you need something beyond basic, just firewalling, egress, ingress, east to west, you want to do something like auto scaling, for example, or you require connection draining. So if a firewall is pulled out of the mix, existing flows aren't affected, then you'd probably want to go with this design. However, if all you require is a performant design, then the previous design is perfect, and it doesn't incur any costs associated with Gateway Load Balancer or with NAT gateways or anything like that.
Well, that's a great point. The cost is obviously very important for a lot of customers. So basically what I'm hearing that the previous design is perfect in cases where you have a very deterministic performance or throughput requirement. You know exactly the number of firewalls you're going to deploy for your traffic load. Um, but if you have a requirement where your firewalls might go up and down, you might need auto scaling. You have a varying nature of your traffic coming in or leaving from your setup, then I think this would be better. But obviously, with the cost that you keep in mind, and obviously it goes back to the design choice a customer has to make.
Yep, that's correct, Shazad.
Cool.
Now here we actually can separate out your east-west traffic and your egress traffic. So what this does for you is that you can have either different design patterns, different firewall vendors, different licenses on your firewalls. It gives you a lot of flexibility here. So some of your traffic can go here for your east-west, and for example, you could do auto scaling here depending on your internal load, and you could do minimal threat prevention if you trust your internal workloads. And then here you could, just for egress purposes, you could deploy our simpler non-gateway load balancer design if you wanted to, and use a firewall license that contains threat prevention, for example. And this just goes to show that Aviatrix provides a lot of flexibility in your design choices. So whichever works better for you is, what you should do. We're not going to stop you.
Yeah, that's a great point again, because I know some of my customers, they opted for the dual FireNet or dual transit FireNet design as you are depicting here. So on the right-hand side is the Egress FireNet solution, which takes care of all the traffic going towards the internet, the egress flows. And then on the left-hand side, we'll take care of your east-west or the traffic coming in from on-prem, for example. And I see this is a choice that most of the large enterprises are making, because oftentimes their policies also conflict. The egress team might be a different team versus the team handling the east-west firewalling. So I think this is a great design choice we have for our enterprise customers.
Absolutely. Now, someone asked about Ingress, and we definitely can do Ingress here. The best way to do Ingress for your web applications is to put it could be your public ALB, it could be a third-party device, whatever you like. We're flexible, and deploy that out in an Ingress spoke. That way, the traffic is actually natted or proxied at this ALB location or a third-party device, and it looks like east-west traffic. So the traffic sources from the Ingress spoke, and it goes through the Transit FireNet, is sent to the firewalls for inspection, and then sent to a backend application. And it doesn't really matter what the backend is. I mean, as long as it's web-based, it can be an EKS cluster, it can be an app server, it can be an ELB sitting in front of a pool of app servers, really whatever you want. Very flexible design, and you get all the security inspection you could get from your firewall.
Yeah, I think this is great. Why? Because in the previous slide you showed the collapsed model where your firewalls were taking care of the egress and also the ingress and east-west flows, which is totally fine based on the requirement. But you're right. I have seen some customers, they would like to treat the ingress flows as east-west flows. And I think it's a great option to drop the traffic into this ingress spoke VPC on the top right corner. And maybe you want to deploy some load balancer there for some massaging for your HTTP or HTTPS flows. Maybe you want to send it to different Kubernetes cluster based on the requirement, and create the policy right on that spot to make sure when the ingress traffic coming in, it knows exactly when to hit the firewall for the destination workload.
All right, now I'm going to show how to actually deploy the Aviatrix Transit FireNet solution on AWS. And for the first steps, I'm going to use our Aviatrix Sandbox Starter tool because it's a very convenient way to deploy a full-blown AWS Transit as well as a couple VMs for testing purposes. So I recommend that you take a look at that. So we're going to be deploying in US East 1, and the diagram here is exactly what it's going to look like. We're going to have a couple of VMs, and we're going to have the Aviatrix gateways, 2 spokes, 1 in each VPC, and a transit gateway. I'm going to go through this kind of quick in the interest of time, and the slide deck will end up being posted later. So if you want to go through a little slower, all the details are actually on the slide for the deployment. To start using the tool, you need to install Docker on either your PC or laptop or on a VM. It doesn't matter which. I was using a Debian VM in this case here. These 2 commands need to be run to actually deploy the Sandbox Starter, and then you can just go in your web browser to the IP of your Docker host on port 5000, and you'll be right into the tool.
Cool. So how can I install Docker?
If you go to Google or Bing or whatever your preferred tool is, you can install Docker on and then whatever platform you're using. Docker has tutorials for Windows, for Mac, and for most popular flavors of Linux.
Got it. And one more question I see popped up is, do I have to use the Sandbox Starter to deploy this?
Oh, no, absolutely not. You can, if you want to, just install the controller yourself and then start deploying your spokes and your transits and your VPCs. You can definitely do that as well.
Cool. Yeah. So I would like to highlight that this is a tool that we created for quick cloud and multi-cloud deployments called the Sandbox Starter. If you go to community.aviatrix.com, search for Sandbox Starter, you will find that tool, and you can use it to deploy controller and the transit and other features as you want.
Cool. So once you go to that web page, you'll see a little pop-up there that asks if you want to do standard or advanced mode. Let's keep it as standard and then just click done. Advanced lets you specify CIDR ranges and deployment locations and stuff like that. And for this purpose, it's not necessarily relevant. So you move on and you add your AWS credentials here. You'll have to go into security and get your an access key and a secret access key. Make sure before you even attempt step 2, make sure you do these prerequisites, because you'll get an error if you're not subscribed to the controller. This is pretty typical for third-party AMIs in their marketplace. So you go through these parts, enter your password that you want to use for the controller, and then hit continue. It'll deploy the controller. It takes a few minutes. It's deploying the AMI for the controller, spinning up the VM. And then once that's done, you can actually start deploying the transit, and this will deploy your spoke and your transit gateways. Once that's done, you'll be asked if you want to deploy EC2 instances, and click yes. These are Amazon Linux instances, so you just have to SSH into them, and and it looks a lot like CentOS or Red Hat or one of those. So you'd be able to do any kind of testing you want, just verify your connectivity. And prior to actually deploying these, you'll want to create a key pair that you have the PEM file for, and you'll just enter the name that's in the AWS console. In this case, I just created a key pair named Sandbox Starter. Keep it nice and simple. Once the EC2 instances are deployed, it'll ask you if you want to launch Aviatrix Transit in Azure. For these purposes, you want to just say no, because we're focusing on AWS here. However, if you do click yes, it's a great way to learn about the transit in Azure, and you can actually see for yourself that, yes, with this configuration, you can talk from AWS to Azure, and it's transparent and it's been done for you. All the routing, all the connectivity, all the security groups, anything you could want. So once you're done there, you'll have a nice success banner, and you'll have private IPs, public IPs that correspond to the EC2 instances, as well as the URL for the controller. So you'll want to just go to that URL for the controller. So now that we have a full-blown transit deployed here, and at this point, you can just SSH into those EC2 instances and test it out for yourself. It's already fully functional. That's the beauty of the Sandbox Starter tool. It enables you to try it out and see the simplicity that is Aviatrix. So, okay, go ahead and log into the controller, and with your admin username and the password you created when you were setting things up. So the trick here is that when we deploy the gateway, it's something pretty small, because we want to be frugal with our use. We don't want to waste your money on a demo. So to enable FireNet, we actually need a gateway that can handle 4 ENIs, because we use the ENIs for different purposes in the FireNet solution. So what you want to do is, first, you just want to resize your gateway. So you go to Gateway, click Edit on the Transit Gateway. Don't have to worry about the spoke gateways, it's just on the transit here. And choose T3A X large is a good size. You could do T3 X large. There's a few sizes that'll work. So you just click change and then confirm it and just let it go. It only takes a couple minutes to actually resize it.
Actually, this is very powerful because like you said, Matt, you can start with a small instance size, but if you need to change the instance size, if you want to scale up, you can easily do that within the controller UI itself. It's really nice.
Yep, it's very flexible, again, so you can go up and down as your needs dictate. So once that's actually resized, we can go into this Transit FireNet workflow. So you'll want to select your gateway. It'll only allow the transit gateways, and check the box for use AWS GWLB, and then click enable. Now what this is doing for you actually is deploying the Gateway Load Balancer, configuring those NICs that we talked about in the previous slide, setting up the routing, setting up the security groups, doing everything for you. There's endpoints that need to be configured. All of this is done. So when you click enable, it's doing a lot of work behind the scenes. And if you want to check it out in the AWS console and just see what's going on, you can, and you'll see the amount of work that the Aviatrix solution is actually doing for you.
Man, that's great. If you guys recall, if you are watching this video, you can go back and look at the route table being programmed and everything that you need to do to make this gateway load balancer integrated in the solution. But here you can see on the screen, it's just one single checkbox or a Terraform, and that's it. It will enable the gateway load balancer, not only with all the routing and everything, but also the policy that you need so that you can specify the VPCs that you want to inspect through this solution. It's great. So one more question I'm getting here is, are there any additional steps of enabling gateway load balancer?
From the Aviatrix side, there aren't any. And from the AWS side, all we need to do is collect the VPC endpoint names and the IP where the health probes come from. Of course, configuring the Palos is a separate issue as well.
Mm-hmm. Okay.
So here in the AWS console, this is what I'm talking about here. This has all been created for you, so we just have to get the information. The VPC endpoint here is the endpoint that we actually send traffic to. And this IP here, the .182 IP, is the health check IP. We also want to pay attention to our availability zones. It's worth noting that if you're doing the sandbox starter, again, we're being frugal here. We're doing non-HA deployments, so just one gateway. Of course, for production, recommend doing the HA version. So if you're doing this in a HA scenario, you'd have 2 availability zones represented, and you'd have 2 endpoints and 2 ELBs here. So you'd have to collect multiple IPs here. So now back to the controller. This is another thing that we take care of for you. You don't have to actually launch the firewalls within the AWS console. You don't have to do anything like that and have to guess at where you want to put your interfaces with the Aviatrix solution. We handle all that for you. We associate it with the gateway for you because you have your transit gateway, your transit FireNet gateway that needs to know about the firewall. So that step is handled. You can specify your SKU that you want. In this case, bundle 1 is a pay-as-you-go SKU. You can specify the version. Anything that's currently available in the AWS marketplace, you can choose. The firewall instance size is what's prescribed by the AMI. And then all you have to do is make sure you're specifying the right availability zones. And then that's it. Additionally, I did specify the sandbox starter here, but that's optional. Aviatrix will create a key pair for you here, and then you can download it after the firewall has been deployed. I just reused it, so I don't have too much in the way of key pair sprawl for this project. Then you click launch, and that's really all there is to it here. It's going to attach, and you'll be good to go. After it's launched, you'll see a line that's right below this launch button here from the previous slide with the detail here. In this case, it's a PAN firewall, and you get the management UI information and then the key name. If you had opted to let Aviatrix create your key, a little further over, there'd be a download button, and you could download the PEM file so you can actually connect to the instance. In this case, if we actually looked at it, the download wouldn't work because it's a pre-existing key and we'd have no knowledge of it in Aviatrix. Now here's what Shahzad was talking about earlier. When you create your the FireNet initially, you have to specify your spoke inspection policies. And in this case, the default is that nothing's being inspected. So we want to click add for each individual spoke to pull them into the inspected column. And now what that means is that traffic destined towards those spokes will actually be punted to the firewall for inspection. So you can block, allow, do your antivirus, do your anti-spyware, data loss prevention, what have you, and then it'll come back and actually go to the spoke.
Cool. I see a question here about the Terraform. So can I write this policy using Terraform? Can I automate this?
Yes, absolutely. Yeah, you can create your policy in Terraform and have it turn it on, turn it off, however you like. Everything that's currently in the controller as far as configuration can be done through Terraform.
Awesome.
One thing I should mention here too, is that when you enable this, Aviatrix handles all your routing on the back end as well. I mean, that's kind of a theme here, that we take care of all the nitty-gritty behind the scenes for you. So you don't even have to think about, aside from clicking that add button or running your Terraform, you don't have to be modifying route tables or security groups or anything like that. It just works. Now, we want to enable also traffic going out of the VMs to the internet. We want to make sure that is inspected. So that is as simple as going to advanced, clicking the dots, and choosing enable for egress through the firewall. Now, what this does is that it programs the route tables on all of your private subnets to send the quad 0 directly to the spoke gateway, which then sends it to the Transit FireNet gateway, and then out to your firewalls.
Yeah, so this is very powerful. With a single click, you can enable the egress, and like you showed in one of the pictures, the collapse model. Now you have enabled the collapse model basically to inspect the traffic between the VPCs, same region, across regions, even across multiple clouds, and also of the egress traffic and the ingress traffic.
Yep, you're exactly right. That's the model I was emulating here. Now we're going to move into, and again, this will go pretty quick because it's just a lot of typing. We're going to configure the VM series to make it work in this solution. And this would have to be either repeated on each firewall or use a management solution panorama to actually do this. So the first thing we want to do is use this sandbox starter PEM key or the PEM key that you created to actually SSH to the firewall. AWS and GCP, for that matter, require the use of SSH keys for connecting to instances for Linux and similar type devices. You can't use a password like you can with Azure. So once you're logged in, you want to run these 3 commands here. And note that in the red box here, we have that VPC endpoint we collected from the AWS console earlier. And then after that, we want to set the admin password because we're going to want to log into the GUI of the Palo Alto. So you commit and it's done. Now here's where we get into the blocks of text. This can all, of course, be done from the GUI, but it's easier just for the sake of this. If you're just trying to repro, just paste a whole block of text in there. So we have to create a management profile, and the purpose this serves is for the health probes to respond to something, because we need to know if the firewall is up or down. So this enables the Gateway Loadbalancer to check the HTTPS management, and it'll reply if it's working, otherwise not. Have to enable all the interfaces, use DHCP. Our egress is on Ethernet 1.1, so we want to get the default route, otherwise not. And the health probes from the Gateway Load Balancer are checking Ethernet 1.2. So we want to bind that management profile to that interface. Set our security zones here and add these to the default virtual router instance.
Okay, so I see a question about, can I do it from the UI, from the GUI?
Yes, actually you can. You can do this section either from the GUI, from the API, if you like writing XML, you can do it from Terraform, and you can do it from the CLI. So there's quite a few options.
One more question that just popped up is about your previous slide. So the commands that you entered, what were those for?
Let me go back to that slide real quick and I'll just point them out. The first one enables the Geneve tunnel feature within the Palo Alto. As you may recall, I mentioned that the GW Load Balancer, it uses a Geneve tunnel to send traffic to the firewalls. So this turns on that feature. It's part of the AWS plugin for VM series. The second one enables internet traffic to actually break out. And really what this does for you is it enables routing between security zones on the Palo. Now the Gateway Load Balancer itself won't do the routing. So you'd have to have, for example, multiple instances of Gateway Load Balancer and it would get really messy. But this enables you to have, say, like what I showed on the next slide, your internal and your external zone and enable routing between them. And the third one finally is this VPC endpoint. We want the firewalls to be aware of the VPC endpoint because that's included in the Geneve packet. And that way it knows that is associated with this Ethernet 1.2 interface. Now, if you had multiple firewalls here like an HA, you'd only put the endpoint for your given availability zone here. Now back here, once we're done with the interface configuration, we want to commit and then exit the configure mode because we need to find out what the gateway IP is for Ethernet 1.2 for that internal facing interface. I mean, we could calculate it from the subnet range, but this is a little more pleasant, I think. So going back into configure mode, we want to start doing our static routes. So basically all we want to do is send all the traffic for the RFCs back to that gateway IP we just grabbed. And recall that the Egress interface actually has the default route. So we're good there. We don't have to do any kind of static config for that. And on that topic, we want to be natting anything outbound on Ethernet 1.1 for egress. So pretty much everything from the internal to the external zone goes out Ethernet 1. It'll just be natted to the IP of Ethernet 1. Now we get into this security policy rules. This is the health check. So that way the management plane will actually reply back. And we have to allow that traffic explicitly. And that's for good reason. We don't want anybody to be hitting that. So we create a rule here for internal zone only. And the source is that IP we collected from the AWS console. That is the source where you'll see all your health probes coming from. And also, if you have multiple availability zones, this IP may be different depending on what AZ you're in. Or if you've deployed firewalls across 3 AZs, you might even have 3 firewalls or 3 IPs to contend with. So we're just allowing on HTTPS. It's just a simple TCP ping, and that's all there is to it there. And since this is just for fun, just for a test, we're going to allow all traffic to the internet. Obviously, in a corporate environment, you're not going to do that. Palo by default has intra-zone and inter-zone routes. So we're going to add logging to this intra-zone. So that way we can see the traffic that's actually flowing between internal, our east-west traffic. We commit. So now at this point, we're just going to do some testing here. We can ping. And remember, this is going through the firewall. So we're pinging there. So it's going to show up on that intra-zone rule. And then we can even SSH as well. Of course, I got access denied because at this point, I hadn't uploaded the private key to this VM. But still, that'll show up on CoPilot and the firewall logs. Now, testing egress involves just a little more work because that sandbox starter tool, it deploys those VMs in a public subnet. And that's kind of obvious because we saw public IPs for each VM in the spokes. So we have to do a quick deployment, deploy another Linux VM. I just did another Amazon Linux VM in one of the private subnets. And then I finally uploaded that sandbox starter key to the Spoke 1 VM so I can actually connect to this new one. And then I SSH to it. So I was able to curl ifconfig.me, which is a handy way to figure out what your public IP is. And indeed, it's the IP of the firewall, the Egress, the one I netted to. Then I was able to curl my company's website and curl AWS website. And it all just kind of went through and worked, no problem. So now we're getting on to the verification. I mean, yeah, I told you it worked, but did it? So let's look at this. This is CoPilot that Shahzad mentioned earlier, and we can see from the source to the destination, this is the SSH session.
So why is each flow shown 3 times here?
Because we record every hop on our gateways. So each of these correspond to a public IP of one of our gateways. So we're going to have Spoke 1, Transit, and Spoke 2 when it finally lands. You're not going to see the firewall hop in this because the firewalls are not an Aviatrix gateway.
Got it.
Also, we have here the internet and egress. So I just picked the private IP of my internet capable VM, the one that's actually going through the firewalls. And then I kind of had a start initially. I saw all of these different names and it's like, why would I be going to something on fancube.com? I have no idea what that is, or Ekvia. I mean, what are those? So I modified the columns over here and I added the destination port. And it's 123, which is it's NTP. So that explains it. Where the VMs, Amazon's VMs, reach out to a whole variety of IPs here for NTP configuration. My guess would have been they would have used an Amazon server, but obviously not. We can also see some additional just regular web traffic here, which I'll get to in just a second. So here we are. I filtered the list down to just show the tests we made. Google user content here, there's 2 different IPs for those, and those correspond to the Aviatrix and then the ifconfig.me, and then CloudFront is obviously Amazon. And in this case, we only see 2 entries per, because when the curl request is made, it hits the Spoke gateway and then the transit, and then it goes out the firewall. We don't see it again.
I just want to quickly highlight that the CoPilot, what you see here is could be just 5% of the CoPilot. It's extremely powerful tool. And I will encourage you guys to deploy yourself with the Sandbox starter or join one of our office hours and request for a demo.
The nice thing about CoPilot is that it's actually ingesting NetFlow from all of the gateways. So if you have any familiarity with NetFlow, you know the richness of data it can offer. So we have access to all that in CoPilot. You can look at trends, you can look at, edit the columns if you want to see the actual flows, different details about those flows. Really, there's anything that goes through our gateways will show up here if you have it configured. And last but not least, we can see the traffic in the Palo Alto logs here. This is just a snippet from basically all our VMs. And we can see the internet egress VM, the one that's using the FireNet. We can see that it's using the firewall for external traffic here. That's likely the ifconfig.me because it's port 80. And then we can see more connectivity here. This is probably Aviatrix. Then we have some CloudFront stuff. Then we can see pings between, because I was doing some test pings. So all the information you could want is between here and CoPilot. And there's really no better way to get visibility into what's actually going on your network. Worst thing is you're trying to troubleshoot, you're getting audited, your security guy is breathing down your neck and you don't have that information. And I don't know is not a good enough answer. Now, last but not least, no Aviatrix talk would be complete without discussing multi-cloud a little more. So here's my design for multi-cloud across AWS, Azure, and GCP. These are all FireNet. They all have firewall insertion. They have different applications running in them in the different spokes. And basically this diagram was a copy paste. I copy pasted the AWS design and changed some of the colors, some of the icons. And deploying this in the tool, in the controller, in Terraform, just as easy. There's really not much to worry about. When you deploy the FireNet solution, you can get a Gateway Loadbalancer in AWS, you get your HA Load Balancer in Azure. It creates the TCP and UDP load balancers required in GCP. And as you can see, this is repeatable. It all works the same way. It reduces your complexity immeasurably. It's not like you have one firewall design because it works one way in one cloud and another in another cloud. It's all just there. And in all cases, you have visibility with CoPilot. You can choose what to inspect, what not to inspect. I mean, the sky's the limit here. Very, very flexible.
Exactly. And this is exactly the power of Aviatrix platform that is providing in single cloud or across multiple clouds. And this is where the unified control plane comes into picture, because we have this, the controller that I showed you in the beginning, the brain of the solution, that is managing all the native constructs, third-party firewalls, our gateways, and whatever goes in between, right? So you're creating the policies, you're creating the segments across multiple clouds, and those are actually pushed down to the respective places. So you show your intent, and then we will program and make it happen for you. So I guess the last question I saw here was about the sandbox starter. Can you tell us if I can use sandbox starter and make it production grade?
Sandbox Starter, you could. I mean, you can use Sandbox Starter as a basis for your POC deployment or even a production deployment, because Sandbox Starter is deploying the real deal. It's real controller. I mean, the gateway is all up to date. You can always turn on HA if you deploy it and you just have your single transit gateway. You can always add HA to that, or you can add HA to your spokes. Then you can use the same controller to spin up in Azure and GCP and OCI, and it all just kind of works. It's all there for real, and it just works. It's a great way to get started.
Got it. All right, so that actually ends the main discussion points in the main session, and let's move on towards the end of our presentation.